Rates, electricity example. We've got this example where an exercise bike at the gym is used to generate energy. On average, bike riders generate 100 watts of energy per hour. A watt is a measurement of amount of electricity, so something like a light bulb might take 60 watts, a kettle might use 2000 watts, which is 2 kilowatts, because a kilowatt is 1000 watts. So we're assuming that the bike is used for 6 hours a day, 364 days a year. Normally the gym pays 54 cents per kilowatt for electricity. How much does this bike save them in a year? Now, to be really technically correct, normally electricity is billed in kilowatt hours. That means you used a kilowatt for a full hour. So that 2 kilowatt kettle that I mentioned, to use a full kilowatt hour, if you used that for an hour, you'd use 2 kilowatt hours. So 1 kilowatt hour would be using this kettle for half an hour. But we're just going to simplify it and work it out as paying in kilowatts. So we need to know how much the bike saves them per year, so we need to know how much electricity the bike makes in a year. 100 watts of energy per hour, and it's used 6 hours a day. So 100 times 6 is 600 watts per day. 364 days a year. Underneath this, if you want, or instead we can just go, we can use a rates system where we just work down the page, or since we know it's 600 lots of 364, 600 times 364, grab our calculator, $2,118, 400 watts in a year. Now we want this in kilowatts, so we'll divide by 1,000. 218.4 kilowatts in a year. So that's how much electricity the bike generated. At 54 cents for every kilowatt, how much was the saving? Savings, 54 cents times the number of kilowatts. That's already in my calculator, 218.4 times 0.54, because we've got to have that in dollars. And they're saving $117.94 because we round to the nearest 2 decimal places for money.